Hello everyone! Today I released a hair simulation extension for Blender on GitHub, so I am making this video to show how to use it. In this video, I will explain the basic workflow for the YURAMEKI solver. I will assume that the extension is already installed. Here is the character's hair. Right now it is in what I call the sea urchin state. The strands have been generated, but they have not been simulated yet. The hair is a Curves object. There are about 6,000 strands, which is not extremely large, but also not a tiny amount. This hair was also created with an extension that I released on GitHub. It is called TOKOYA. TOKOYA is released under the MIT license, so you can use it freely. YURAMEKI, the extension I am showing today, is also released under the MIT license. The physics runtime used by this solver is TOKOYA, and TOKOYA uses the Apache license. So both can be used freely, but please note that the licenses are different. Now let's use the solver. As I mentioned, the hair is in the Curves object. This body was created with Character Creator. First, in the end panel, I select the body mesh. Here it is named CC Base Body. Next is the clothing. This clothing was made in Marvelous Designer. I ran the cloth simulation there and imported the result into Blender as an Alembic cache. The body mesh was also exported as Alembic. And the finished clothing was imported as Alembic as well, so it moves together with the character. Strictly speaking, the clothing itself is just animated geometry moving through space. We can also set this clothing as a collision target. The clothing target is optional. Using only the body is also fine. Below that is the GPU selection. Here I select CUDA. Even with CUDA, the simulation takes some time. But without CUDA, it takes much longer. It is still a simulation, so it is not instant. But compared with running the same kind of long hair simulation in Vellum, it is much faster. Next, I press the button labeled Condition Groom. This button is optional, but if you do not run it, the simulation is more likely to fail. When you press it once, the roots of the hair strands are moved just a little bit away from the body surface. The current frame simulation button does not create an animation. Instead, it simulates the hair several times on the current still frame, so gravity can pull the hair down. You do not need to run it 20 times. Around 3 steps is usually enough. I typed 5 here, so 5 steps is fine too. At the bottom, there is a gravity setting. Right now, gravity is negative on the z-axis, so it points downward. For long hair, I first want the hair to fall backward, so I change the gravity direction to the y-axis. Earth gravity is about 981, so I set y to 10 and z to 0. Now gravity is not pulling downward. It is pulling backward, so the hair will be simulated toward the back. I run the current frame simulation. From the side view, you can see that the hair has moved backward after only 5 steps. Now the hair is below the shoulders, so if we continue from here, it should naturally fall down along the back. If we keep simulating with this backward gravity, all of the hair will continue moving backward. So first I restore gravity. I set y back to 0 and z back to 9.81. Below that, there are start frame and end frame settings. These define the range that will be simulated. To run it, you press the Simulate Range button. There are several parameters below that. Changing these parameters will change the simulation result. The parameter that affects simulation quality the most is interpolation molt. It is currently set to 1. This means the solver uses the minimum number of simulation steps. If you set it to 2, the solver calculates twice as many steps, but the simulation time also roughly doubles. If you set it to 3, the quality can improve further, but the calculation becomes heavier. For this demo, I will keep it at 1. In general, a higher value gives a cleaner result, but costs more time. This value here is currently 8. This is a matter of taste, but after testing several settings, I usually set it around 20. Before running the simulation, there is also an option called Auto Frame Interpolation. If you turn this off, and the value is 2, The solver calculates 2 steps between each animation frame. If you turn it on, the solver checks how far the head moves between frames and automatically subdivides the frame more finely when needed. In other words, when the head moves a lot, the solver automatically uses more steps. When the head barely moves, it uses fewer steps. This reduces the total simulation time. If you turn this off and set the interpolation value very high and also raise the other multiplier, you could calculate 100 or 200 steps between frames. That can make the result very clean, but it takes a very long time. So the practical approach is to let the solver automatically use more steps only when the head moves a lot. The simulation range is already set, so now I press Simulate Range. Go. The simulation has started. There is one important thing I want to mention. Why did I develop this? And how was it developed? First, why did I make it? I think simulation is something where, if you have 10 artists, you get 10 different preferences. So I made this as my own hair simulator for the look and behavior that I personally wanted. But there is a small question here. Can I really say I made it? I definitely designed the behavior and decided what I wanted. But the actual implementation was done with a modern AI coding agent. There are many AI agents now, and I am not saying one is always the best. At the moment, I am using Codex with GPT-5.5. So if you feel that this extension is not quite what you want, or you want a different simulation style, you can ask a coding agent to modify it. In many cases, that is enough to make it work. I would not say that I cannot write Python, but for this extension, I did not write a single line of Python code myself. I explained what I wanted to GPT, and the coding agent implemented it. So even if you do not have deep programming knowledge, once the project has reached this point, I think you can adjust the simulation to your own taste. The simulation takes some time, so I will cut this part of the video. The simulation has finished. While it was running, the Simulate Range button was red. Now it has returned to its normal color. Let's preview the result. The animation is from frame 1 to frame 240, so I start playback. The hair comes down as expected. This is roughly the result I wanted. If you assign a material, the hair will render with color. When rendering with cycles, you also need to set the curve thickness. You can see that some areas of the hair are slightly messy toward the back. At the beginning, the character is in an A pose. This is because the clothing was dressed in marvelous designer, and this pose is needed to put the clothes on correctly. If there are areas that bother you, you can of course increase interpolation, mult to 2 or 3, and calculate a more detailed simulation. But as a simpler option, I added 3 cleanup buttons. When you press Clean 1, the button turns red and the extension checks the full frame range. It repairs strands that are floating away slightly from the surrounding hair. This solves some of the small issues. I accidentally played the animation backward there. Sorry about that. The small issue around this area has been fixed by Clean 1. Next, Clean 2 is a stronger cleanup function. After running Clean 2, the result improves a bit more, although it is still not perfectly clean. Clean 3 is the strongest one. It removes most of the obvious problems, but it also changes the taste of the simulation slightly. So these cleanup tools are something you use according to your preference. I will press Clean 3. Done. You can see that most of the large stray hairs are gone. It is not completely unchanged, but the big problems are mostly removed. How the hair curves away from the head can also be adjusted. For example, if you loosen the bending constraints, the hair becomes softer and tends to stay closer to the scalp. But when the hair is close to the scalp, you need a higher interpolation setting to simulate it cleanly. Otherwise, hair strands can collide or tangle with each other, and that can cause the simulation to explode. So the question becomes, can the issue be fixed with cleanup? Or should you spend more time on a higher quality simulation? That is the basic workflow. The program I uploaded is free for everyone to use. Please feel free to modify it and experiment with it. Thank you for watching.